thank you for coming. Are we ready for things to get real slow and boring? I have a friend, an engineering manager, who always talks about how he wants to get ripped. He wants a nice six-pack. He's working out, mainly walking from a meeting to meeting. Just kidding, no one does in-person meetings these days. Anyway, one day we meet for lunch, and he starts telling me how he wants that six-pack. He's getting it any day now. To which I point out, he's been going on and on about it for well over a year, and here we are, sitting in an Italian restaurant, and he's pigging out on lasagna. Now, in that case, it was fairly easy to show how his behavior, overeating lasagna, stood in the way of his goal, having a six-pack. But when talking to engineering managers about building reliable software, it's not always that easy to demonstrate how some of the things they do directly undermine that reliability. When the topic of software reliability comes up, most people immediately think technology. How many replicas, where to put proxies, which observability tools to use, whether to self-host or run in the cloud. And all of those are very important questions to answer. The right technology decisions are necessary for reliable software, but they're not sufficient. That's because when it comes to building software, there are a number of common patterns that are an equivalent of a lasagna. They are tempting, the picture looks good in our heads, but will completely derail our efforts of making the software reliable. I'm Dorota Parad. I work at Authres, which is a login and access control API. So if you're writing software, you want your users to log in or have different roles with different permissions, you can either code those bits yourself or use Authres. And based on what Authres does, dealing with identity and access, you can imagine that we are on the critical path for our customers. So if Authres is down, best case scenario, our customers' users will get annoyed. Worst case, our customers may lose a lot of money. That's why we offer 5 nines of uptime on our critical API routes. That's for everyone out of the box. And 5 nines, that means that those routes can only be down for about 5 minutes in a year. 5 minutes per year. That's, for the record, less than the most recent AWS or Azure or Cloudflare outages. It's brutal. My microphone stopped working. Can everyone still hear me? Okay, good. Then let's continue. Now, at the same time, we're a very small team. We're less than 20 engineers. We don't have a giant customer support organization to deal with outages or try to placate our angry customers. No, when we're down, it's too late. So we had to figure out a way to make sure that those critical routes simply never go down. And as I mentioned, technology is important, but there are a number of things that come even before technology that are often overlooked. When we want our software engineers to produce reliable software, we have to provide them with an environment that, at the very least, will not hinder making reliable stuff. But ideally, it should encourage it. So let's start with the easiest one, capacity. Maybe a little thought exercise. Let's say we have 3 software engineers, full-time employees. How much engineering capacity do we have per week? Most people would say something like 120 hours, right? 40 hours per person per week, times 3. Or maybe 15 days. And that is wrong, obviously, for many reasons. But this is how we tend to think about it. Whenever we do any sort of headcount or project planning, we assume that every person, every team, all our organizations are going to work at full capacity at all times. Right. Now, if we have something that produces output, it can be equipment, machines, manufacturing equipment, or computers, servers, or it could be people, software engineers. So any sort of process that produces output over time. Do you know what happens when we run that at full capacity, at 100% at all times? Yeah, things break. Equipment fails, servers crash, people make more mistakes. Many years ago, I worked as a software tester. So I would find problems, break the software, complain, and people would pay me money for it. It was great. And then there was this very important project that I was part of, super high stakes, tight deadlines. And normally, I would find a bug, report it, go talk to the developer, we would discuss what caused it, and it was the beginning of my career. So I had no idea how the world worked. So my expectation was that once a bug gets handled, I won't see it ever again. Well, I kept finding that same type of bug in different variations, again and again, different parts of the software, and it was often the same developer that I ended up talking to. And it bothered me. So I started making suggestions. Maybe we should change this or adjust our process that way so that we don't see that bug again. And that poor developer, still remember his face, would listen, agree, say they will work on it, and nothing would change, of course. But this went on, and the deadline kept getting closer, and I kept finding that same type of bug again and again. And I kept making those suggestions. And then one day, the project manager came up to me, all serious looking, sat me down in a room, and very sternly asked me to stop distracting the developers with my suggestions. Because they're busy. They have no time. They are working on this important project, and they already have to spend extra hours fixing problems I'm reporting. I was very confused. But this is what happens when every single working hour is accounted for, when we plan the work with the assumption that everyone will work at full capacity at all times. And it reminds me of that old joke. Don't know if you know this one. A supervisor visits a construction site. The work is in full swing. A lot is going on, and there's this one guy running back and forth with an empty wheelbarrow. So the supervisor asks, "Hey, what's going on? What are you doing? Why is your wheelbarrow empty?" So the worker responds, "Oh, boss, there's just so much to do. We're so busy. I have no time to stop and load it." When every working hour is accounted for, we have no time to stop and think. What are we doing? Why are we doing this? Is there a better way? We have no time to look back at the work we've already done and see if we could do it differently, maybe better. We barely have time to fix our mistakes, let alone prevent some future hypothetical mistakes, and we make more mistakes in the first place. Mistakes mean suboptimal decisions, problems in production, issues, outages. That doesn't really sound like an environment that will encourage a lot of reliability, does it? But it happens all the time. Whoever makes the decision on how many engineers to hire, what to promise to customers, or when the release should go live, they tend to assume that all the people, all our teams are going to work at full capacity at all times. And if our main work doesn't take up all the time, we add side projects. If everyone is not super busy at all times, we just add more work. If we want our engineers to produce reliable software, we have to slow down. We have to make sure that there is some slack in the system, some buffer, so that everyone has the time and mental space to just stop and think about the what-ifs to notice alternative solutions. So we really cannot be running our teams at 100% at full capacity at all times. Now, what is the capacity? What is the level of workload we want? That depends on a lot of factors, as always. A good rule of thumb is about 80%. So, when planning your work, only account for about 80% of your theoretical maximum available hours. Leave the rest wide open, unaccounted for. That's what we do at Authors. And I may prefer this to be 85%. Engineers would prefer this to be 5%. The exact percentage doesn't matter. What matters is that there is that slack in the system so that people just can stop and think when needed. Now, if you are used to working at full capacity at all times, once you switch to a healthier workload, it's going to feel slow. That's good. We want things to be a little bit slow. US Navy SEALs have this saying, slow is smooth, smooth is fast. We really want smooth. And here's the thing that's very counterintuitive. When things are already breaking, when the world is crashing and burning, our natural instinct is to speed up, panic a little bit, do extra work. No. When things are breaking, it's especially important that we slow down. When the world is on fire, we have to stop and think. Now, some ways of working will naturally push us towards that 100% capacity. I'm talking about Scrum here, which focuses so much on the output, on the velocity. We specifically fill all our sprints to maximum. But it's going to be the case also for any sort of advanced project planning when we do Tetris in a spreadsheet. Many companies still do that for some reason. So if this is how our company operates, we have to be extra careful to make sure that we don't overbook ourselves, which means saying no to our boss a lot. That's hard. It can be career limiting. Not many people can actually pull that off successfully. So better still, we may adopt a way of working that will not naturally nudge us towards that 100% of workload, like Kanban, which is ideally suited for high reliability work because it focuses on highlighting the bottlenecks, on the throughput, so on making everything smooth, and we want smooth. So if you haven't tried Kanban, give it a go. 10 out of 10, highly recommended. So, if we want our software teams to produce reliable software, we slow down, we make sure that there's some slack in the system so that everyone can stop and think. But if we slow down, where is our excitement going to come from? In my last corporate job, I was a product manager. I worked with multiple teams across different continents. We did manufacturing software that was used by our various business units. So a product manager's dream, captive audience. They had to use our software. And no one said they had to be happy about it. Anyway, I remember two of the teams I worked with. One team, let's call them Team Alpha. They always gave it their all. 100%, no, 120%. Whenever there was like a work request from management, extra work, extra feature for Team Alpha, they were there, ready to start working on it immediately. No questions asked. They never said no. Whenever there was any sort of incident involving Team Alpha software, they were there on the emails, on the phone, talking to users, explaining things, debugging. It happened a lot. Our management loved Team Alpha. Our CTO often spoke of them highly. Whenever there was a big team meeting, Team Alpha was there, featured prominently, talking about their latest heroic victory. In parallel, there was another team. Let's call them Team Foxtrot. And you could think they didn't really exist because you would never hear about them. Their software was never involved in any major failures. There was not a single giant email chain with all management on CC involving that team or their software. Now, that team operated and owned a number of critical services, but there weren't that many people in our software organization who could tell you what those services were. Whenever management had some extra work request for Team Foxtrot, there would be questions. Why? Who wants this? What should we stop doing so that we can do this? So you can imagine that our management really didn't like Team Foxtrot. I often heard rumors how we should reorganize them and replace those useless people. Now, as a product manager, I sometimes talked to our users. Imagine that. And interesting thing, whenever the topic of Team Alpha or their software came up, most of our users would just roll their eyes. Now, they couldn't say anything bad to my face because I was part of software organization, but I could tell our users weren't exactly fans of Team Alpha, contrary to our management. And also contrary to our management, they seemed to know and like that other team, Team Foxtrot. Well, our users worked in manufacturing. So to them, software was just a tool. It had to do its job, stay out of the way. In our users' minds, Team Alpha was causing a lot of incidents, outages, where the software was the main star. Meanwhile, Team Foxtrot took great care to make sure that their software just works and stays out of the way. Long after I left that company, I've heard that Team Foxtrot was indeed reorganized and remodeled to be more like Team Alpha. I don't know how our users felt about it, but I heard the management is happy. And I couldn't stop thinking about it. We're talking manufacturing. So if there is an outage, the company is not making money. The company is losing money. So why is it that the team that is causing all of those outages gets all the recognition, while the team whose software just works gets reorganized? And I have seen that pattern in a lot of other companies where the teams that heroically fix the production issues that they themselves cause get all the rewards and recognition, and teams whose software is stable, they get forgotten. And then I caught myself doing it at Authoress. Well, when we like to reward people or recognize our teams for their good work, there is this very human, very natural thing. We tend to reward people when something happens. Obviously, how else would we do it? Yay, you fixed this critical production bug. Good luck. Good job. Great. Well done. Now, guess what happens when we release software that is super stable, that works exactly like the users expected from the get-go, doesn't have any obvious bugs? Nothing happens. That's the problem. Teams that make reliable software tend to be invisible, quiet. They don't make the news. As a result, they are often underappreciated, passed over for promotion, forgotten, sometimes even fired. Unless we take conscious effort to recognize when nothing happens. So this is a task primarily for the leaders. So team leads, engineering managers, directors, but also senior software managers, to remember and notice and publicly bring it up when things are working smoothly. And this is super hard. It is one of the harder parts of my job to remember and remind our leaders that it is good when nothing happens, when things are just working smoothly. Now, here is a little problem with that. We're humans, which means in order for us to recognize that nothing happened, we need some sort of trigger. We need something to happen. What I do is, it will sound cliche, maybe even funny. I use metrics like days since the last failure, however you define failure. It may seem funny, but it works. So use that as your trigger. I also have a number of recurring reminders in my calendar to periodically reflect on just how smooth everything is. So every month, quarter, year, look back and appreciate when things are just super boring and super quiet. And reward your engineers who made sure that nothing happened. Give them a shout out at your next big team meeting. Now, if you're a software engineer, chances are you think your good work is going to speak for itself. Well, if you do a really good job and you write your software really well, it's going to be silent, invisible. No one would know. It's on you to give it a voice. And I don't know how about you, but I personally don't like bragging, but it's necessary. We have to brag. So brag. Let your manager know that you're doing a good job. Help them recognize that you did things intentionally so that nothing happened. Otherwise, they may think it would have worked anyway. So, if we want our teams to make reliable software, we give them time so that everyone feels free to just stop and think. We also celebrate when things are boring, and we reward people when absolutely nothing happens. That sounds like an environment that would encourage a lot of slackers and lazy bums to just come sit and do nothing. Or does it? Well, in reality, there are very, very few people who are genuinely lazy. Most people are happy to do stuff, as long as it's something that is interesting to them and they're good at it. So I'm going to borrow a model from Simon Wardley, Pioneers, Settlers, Town Planners. Simon introduced this in the context of product evolution, but it is a good thing to keep in mind when thinking about reliability. By the way, if you're interested in a product strategy or software as a product, look up Wardley Maps. It's great stuff. So the model goes like this. Pioneers are people who explore the uncharted territories. They experiment, they come up with ideas no one has thought of before. They are the inventors. They move quickly, prototyping, discovering, and they thrive in uncertain and poorly understood areas. Settlers are people who turn ideas into useful stuff. So they polish the unfinished just enough to be useful to someone, bring value. Then they talk to users, try to maximize that value. They bring order to chaos, they productize. They need talking to users or stakeholders in order to thrive. Now, town planners are people who take useful stuff and make it scalable. They standardize, industrialize, they make repeatable, they make things faster, better, more efficient, they optimize. It's not just order at scale, it's consistency. They thrive in predictable and stable environments. Now, think of these not as identities or roles, but more as attitudes or archetypes. And each of these archetypes comes with a dark side, a failure mode. Pioneers build half-baked prototypes. That's what they do. It's part of discovery, which may result in a lot of unfinished, broken, buggy mess, riddled with tech that no one knows how it works. Settlers talk to users and try to please them. That's what they do. It's part of building a product, which may result in a lot of custom hacks, little snowflake solutions, projects that go on forever, and software that's never retired, even though it should be. Town planners, they standardize, introduce process, they codify the rules. That's what they do. How else would you scale? which may result in a lot of bureaucracy, red tape, over-engineering, bloat. Now, every model is wrong. Some models are useful. People in reality rarely fit into some arbitrary boxes neatly. However, most people will have a preference or a mode that they are naturally better at. So it's good to understand which of our people have an affinity for which of these archetypes. Because when building software, depending on what it is, who is it for, what sort of maturity we expect, it calls for a different type of prevailing attitude. When we are prototyping, we really want pioneers. They're going to be the most effective. If we put town planners on our prototyping work, we're going to end up with an over-engineered monstrosity. It's going to take forever. Everyone will get frustrated along the way. On the other hand, if we want to put something out there that's reliable, we really want those town planners. They're going to make sure that everything is nice and stable, predictable, consistent. If we put pioneers on this type of work, well, we're going to end up with a lot of failures. And that's even if they don't get bored halfway and start a project we didn't even ask for. Now, here's a fun fact. You can only have town planners working on your software if you hire town planners. Now, some people can sort of stretch a little bit and operate in a different mode for a time, especially the settler type, but it's going to be most effective when we simply hire people with a natural affinity towards the attitude or archetype that we want. Now, guess who interviews best? When hiring people, we tend to create this artificial, high-pressure, high-stakes environment for candidates that has nothing to do with our day-to-day job. I mean, we're asking people to write code when someone's watching and the clock is ticking. We ask people to tell us stories from their past on the spot. So when interviewing, we tend to favor people who are confident under pressure, talk smoothly, even in high uncertainty, and have great success stories. Yeah, that's exactly where our town planners are going to shine. Now, I could talk about how to hire town planners for another hour, so all I'm going to say is this. Check your interview process, see what sort of candidate it favors, and make sure that this is the type of a person you want for the role. If you're hiring, that is. Chances are you're not hiring, because who's hiring these days? In which case, you are left with the people you already have, but then it still makes sense to see who is working on what type of problem, and maybe shuffle some people around. Yay, reorg! Speaking of organization, I wonder, who of us here works in some sort of SRE role, has a reliability in their job title? Can I get some hands? No one? Good. What about DevOps? DevOps in your job title? We have a few. I'm sorry for what you're about to hear. So I've advised a number of companies that do a lot of things right. They don't pile too much work on their people. They celebrate when things are boring. They reward people when nothing happens. They even hire the right people, people who are like the town planners. And then they put them all together in a single team, entirely separate from the people who are writing software. And they call it site reliability engineering or DevOps engineering, create a whole organization around it. Now, I'm not talking about platform engineering here. That's different. That's when you create those little helper tools for developers. So platform engineering is about making software people, not software, more efficient. I'm also not talking about people responsible for hardware reliability. That's an entirely different skill set, because you need to know when to change your server's nappy hard drive. You need to know which deity to offer sacrifice to so that the DNS doesn't freak out. It still does. No, I'm talking about the situation when a company decides that software reliability is so important that it deserves its own place in the org chart. As if reliability was some sort of add-on you can install separately. Upgrade to a premium tier for more reliability. That's not how it works. Reliability is a property of the software. It emerges as we are writing it, as we're making a lot of those little trade-offs along the way. You can't just tack it on after the fact. So, when we create that separate reliability team, two things happen. One, people who are writing software no longer have to worry about reliability because it's someone else's job. Two, people who are responsible for reliability actually need the software to be unreliable in order to keep their jobs. Do we think this will cause more or less reliability overall? So when we have that separate reliability team, what ends up happening is we end up with a bunch of gatekeepers, slowing everyone down, which may be fair. If we didn't want to slow down in the first place, now we have to slow down extra. But that's fairly rare. In the world of reliability, gatekeepers don't happen all that often. What happens more commonly is that reliability people end up being the janitors. They do the ugly cleanup. They deal with the outages, not prevent them. They're the underdogs. They are permanently swamped with issues they have no real authority to truly fix. They're associated with failure because that's when they're the most visible, and as a result, they're not as appreciated as our heroes writing the features poorly. Your career prospects and consequently your salary prospects are simply not that great when you join a team dedicated solely to reliability. It's sad, but true. Now, I don't know who of you here actually have an influence on your organization structure or can influence that shape. If you can, just consider dispersing your reliability and operations people amongst the software teams. Make them part of making software. I mean, this is not new, hopefully. It's DevOps at its core, the ability to run it. Now, if you don't have that ability to influence the shape of your organization, and you don't think you can plant that idea in your manager's head, you may be stuck with or on that separate reliability team, in which case there is a way to make it work somewhat. That's when we treat that team as a sort of internal consultancy. So they're there not to ensure reliability, but to teach other people how to make reliable software, to provide frameworks, tools, patterns. However, only the biggest organizations with the strongest budget can afford that type of luxury. It is a luxury. However, if you truly care about making your software reliable, we really want that reliability to be everyone's concern. And I mean everyone, not just engineers. It should be managers, maybe even the CEO, definitely salespeople who talk to customers, promise them things, project managers, everyone. It should be on everyone's mind, be part of every decision, every trade-off. Because if we're not prepared to take that step, we're just fooling ourselves, like that engineering manager I told you about who wanted a six-pack while stuffing his face full of lasagna. Now, some of you may think that I actually don't like lasagna. I do. I love eating lasagna. In fact, the picture I've been torturing you with is the lasagna I made. I made a whole tray. I ate all of it. But I don't go around telling people how I want a six-pack. So when you ask any engineering manager if they want their software to be reliable, they're going to say yes. Of course they're going to say yes, everyone would. More reliable is better than less reliable. But does it really have to be? And just how reliable? Like 5 nines of uptime or simply not crashing and burning? In reality, for most companies, majority of their software doesn't have to be all that reliable. Even for authors, some parts of our software aren't. Like, who cares if our UI glitches? So it makes sense to ask that question. Does it really have to be reliable, and how much? And most importantly, does this come from the business? Will the company make more money or lose less money as a result? Will the customers pay for it? Because if the answer is no, if business doesn't care, we don't have to worry as much. But if it is in fact a business requirement, then we have to create that special environment that will be different than what we may need otherwise. And that's a lot of work, especially for the leaders. Because we have to we have to give our people time so that everyone can stop and think, which means managing our work differently, leaving that slack in the system, not working our teams at 100%. We also need to do performance management differently. We have to reward people when nothing happens. We have to recognize when things are stable. We also need to hire different people who are like the town planners, which means an interviewing process has to be appropriate. And we really want reliability to be on everyone's minds, not just engineers, everyone. And all of that, even before we start talking about technology. Now, thank you so much. I know I've been torturing you with that picture of lasagna. It's almost lunchtime. We have some time for questions.